Hello everyone, myself Sneha Murthy. I'm studying in Sri Venkateswara College of Engineering from ISC branch. Today's subject we are going to discuss is computer networks. And the topic is Dijkstra's algorithm for finding the shortest path in the linked state routing. First is the introduction that the Dijkstra's algorithm is a fundamental concept in the network routing. It plays a crucial role in determining the shortest path between the network nodes, ensuring efficient data transmission. This is all about the introduction about Dijkstra's algorithm. Introduction to the line state routing. In linked state routing, each router maintains a complete map of the network topology. This map, called the link state database, contains the information about all the routers and the links in the network. Challenges in the link state routing. First is scalability and the next is network updates. Maintainability, a complete network map can be challenging in the large networks. Network updates, the link state database need to be updated whenever the network topology changes, which can introduce complexity. These are the challenges in the link state routing. Dijkstra's algorithm basis. There are four algorithm bases. The first is initialization, node selection, distance update, and the path construction. Initialization refers the algorithm starts by setting the initial distance to all the nodes. Node selection refers to the algorithm iteratively selects the node with the shortest distance to the source. Distance update refers to for each neighbor for the selected node, the algorithm updates its distance if the shortest path is found. Next is the path construction. The algorithm constructs the shortest path tree between the path and from the destination node. These are all the Dijkstra's algorithm bases. That is initialization, node selection, distance update, and path construction. Next is the constructing the shortest path tree. The algorithm maintains a set of visited nodes and a set of unvisited nodes. This is the first thing we have to do to construct the path tree. And the second thing we have to do is the algorithm iteratively selects the unvisited node with the shortest distance from the source node. The third one is the selected node is marked as visited and its distance is considered final. And the fourth one is the algorithm then updates all the unvisited neighbors of the source node. These are all the four rules we have to follow while constructing the shortest path tree. Updating the routing table. Here there are two types of updating the routing tables. First is dynamic updates and the next is link state advertisement. Dynamic updates refers to the routing tables are dynamically updated based on the changes in the link state database. Third, the dynamically updated based on changes in the link state databases. This is about the dynamic updates. And the next is link state advertisement. When the link state change occurs, the routers broadcast link state advertisement to update other routers. Like we have to update other routers, we have to broadlink the state advertisements. This is about the link state advertisement. So the two updating routing tables are the dynamic updates and the link state advertisement, which are helpful in many of the other ways to update the routing tables. Next is the characteristics of Dijkstra's algorithm. First, there are three characteristics of this algorithm. First is shortest path and the next is non-negative weights. The last one is single source. The shortest path refers that the guarantees finding the shortest path between any two nodes. The shortest path is used to find the distance between the any two nodes which is shorter. And the next is non-negative weights. Works efficiently with the non-negative edge weight representing link's cost. This is about the non-negative weights. And the next is single source. Focuses on the finding the shortest path from the specific node to all the other nodes. It is a single source. It is a main source. It is finding the shortest distance from the specific single source node to the all other nodes. These are the four characteristics of the Dijkstra's algorithm. These are the three characteristics of the Dijkstra's algorithm. Next is the advantages and the disadvantages of this algorithms. First, we can learn about the advantages. The guarantees the shortest paths efficient for the static networks provides flexibility. Though it guarantees the shortest path that it will find the shortest path between any two nodes and efficient for the static networks provides flexibility. It provides flexibility between the two nodes and the efficient static network that the network doesn't fail. And the next is the disadvantage. High bandwidth consumption requires the frequent updates for dynamic networks. That it requires the frequent updates for the dynamic networks and having high bandwidth consumptions. So these are the advantages and disadvantages of the Dijkstra algorithm. Next is implementation consideration. First is the data structures and the second is routing protocols. Data structures refers the choosing appropriate the data structures like priority queue for efficient distance calculation. We can use the data structures for a priority queues for efficient distance calculation. For calculating a distance, we can use the priority queues in data structures. And the next is routing protocol. Integration Dijkstra algorithm into the link state routing protocols like OSPF. This is about the routing protocols, and these are the two implementation considerations which we used in Dijkstra algorithm. First is the data structures, and the next is the routing protocols. Next is the conclusion and the key takeaway. Dijkstra's algorithm, it's a foundation element of the network routing. It ensures the efficient data transmission by finding the shortest paths in the link state routing networks. Implementing Dijkstra's algorithm, it requires careful consideration of the data structures, networks dynamics, and the routing protocol integration. It is a foundation key element of the network routing. It is a main foundation key element of the network routing. It ensures the efficient data transmission. The transmission which is if we the data which is transmitted from the one node to another node, it will find the shortest paths routing network, and the implementation of a Dijkstra algorithm requires the careful consideration of the data structure. We have to use the data structures in this algorithm very carefully by using also priority queues. And the next is network dynamics and routing protocol integration, which we have seen in the implementations and consideration, the network dynamics and the routing protocol integration. This is all about the conclusion and the takeaway of the Dijkstra algorithm. Thank you.